All right, so we are going to be doing the very first section of Chapter 1 called Rational Numbers. This is for Math 8. I'm going to actually go through the ALEKS assignment as we've assigned it for our centers. So you can see that I have unlimited attempts and there are 10 questions. It's not showing me a due date on this one because it's on the teacher side. So normally on the student side, I believe it's the first thing you see here will also be a due date for when the grade will actually be calculated. So it also says once you start the homework, you must finish it before you can work on anything else. And that's the idea of clicking the Submit Assignment button that's going to show up down in the bottom right corner. Once we start it, you don't want to just leave the assignment. You want to actually submit it. Even if you're not completely done, it's unlimited retakes. You can always go back and redo that part. Just make sure that you always submit it. Otherwise, it'll lock you out of everything else until you submit this one. All right, anyway, so let's go ahead and click Start. And it opens up and it's showing me, you can see it kind of looks a little bit like a knowledge check where it's got the numbers up above. On the side here, we have explanation. If I click on this, it will tell me I will lose my current question if I do this. The reason is it's going to show me the answer to this exact question. So it's not going to show me the answer and then let me go and type the answer in. I'm going to lose that. It's going to have a red X on it. I'm going to have to go through and complete the rest of my problems, click Submit, and then if I want to try number 1 again, I have to open the quiz back up, or not the quiz, the homework back up again to do it. So it's just a warning saying, are you sure? You can also click on explanation, which is just a different example. So it's not the exact example. This one's pretty darn close though. And then you can click the little X here and go back to the question that was there. And then there's also Message Center so that you can send a message to your teacher with this question actually attached to it so that your teacher can kind of reach out to you a little quicker on what to help you with. So for some reason, my pen doesn't like this screen. I do have a what would you call that? An extension, I think. One of the things you can download for Google, but for some reason it doesn't work on this page. So I'm going to have my little screen over here open also so I can write things down. So this says write 59 thousandths as a fraction. Do not try to simplify your answer. So if I have 59 thousandths like this, when I want to put it in fraction, what I want to do is I don't want this decimal anymore. So I want to count and go, how many times do I have to move this? 1, 2, 3 times. And then that would be just 59 because I moved it over here. Because I moved it 3 times, that tells me I have 1, 2, 3 zeros. And then I put a 1 on the front. It's always a 1 on the front. So this is the answer, 59 thousandths. So it even sounds like what I said over here. So if it was hundredths, then you'd have a number over 100. If it was tenths, you'd have a number over 10. So it depends on how many times you move that decimal. That tells you how many zeros to put in there. So if I go over here, and I can either click the fraction button first, or I could type in 59 and hit the fraction button. Kind of knows what to do there. And we did the little tools tutorial. There's a few different other things you can do with that. I can click check. And what does it not? Oh, I put 100. Ha ha ha. I just didn't type in enough zeros. I thought I hit it 3 times there. So it was 59 thousandths, not hundredths. There we go. So now, and you can see it gave me another chance. It said incorrect, try again. So it's not just going to be a red X immediately. You have to get it wrong. I think it's 2 or 3 times before you get a red X on there that says you just have it wrong. But it will give you a chance to correct it. If I click continue, it'll go to the next one here. So write 55 as a fraction in simplest form. So this time 55 hundredths. They do want us to simplify this one though. So we're going to take this decimal and go 1, 2, so that I can turn it into 55. I moved it 2 times, so 2 zeros. And with this one, when you're simplifying, you just want to go through your smallest prime numbers there. So the first one would be 2. Well, this one's odd, so it's not going to divide by 2. Then 3, if you know your 3's tricks, that's pretty easy. If you add the numbers together, so 5 plus 5, that gives me 10. 10 can't divide by 3, so 55 can't divide by 3. If you didn't know your 3's tricks, you could just try this out and go 55 divided by 3. Nope, that doesn't work. 4 is not a prime number, so we wouldn't use that one. But 5, ooh, that ends in a 5. That's another one of my 5's tricks. So I can divide this by 5. This ends in a 0, so I also know that divides by 5. So this guy's a little easier. 5 divided by 5 is 1. 5 divided by 5 is 1. 100 divided by 5 might not be as easy, but still not too bad. You can go 10 divided by 5 is 2, and then you just have the 0 on the end. So it'll be 11/20. So if we go over here, 11, and I can also hit the backslash on my keyboard. I don't have to click on this. It'll also open up that fraction bar for me. So check. Yay. Continue the next one. All right. Write 8 3/10 as a mixed number and as an improper fraction. Do not try to simplify your answer. So no simplification on this one. So we have 8 3/10. So if we know how to say this, that kind of helps me too. I know it's going to be 3/10. I can literally hear it's going to be 3/10. But if you don't necessarily know the names, that's the other thing, is just pay attention. I'm moving it 1 decimal place. We're not doing the 8. The 8 is a whole 8 no matter what. So it's going to be a whole number 8. What we're trying to figure out is what is the fraction going to be. Okay, so I'm moving the decimal place 1 time. That'll be 3. And then 1 time would be 10. 1 0 with a 1 in front. So 8 3/10, that's my mixed number, because that means I have a whole number and a fraction. An improper fraction, I take my mixed number and I say, okay, well, these 8 pieces here, for each one of them, there's 10 pieces in it. That's what the bottom of the fraction means, your denominator. So 8 times 10 gives me 80. So I have 80 pieces here. And I have to make sure I add that back to the top because I have 3 pieces on the top also. So 80 plus 3 is 83. And that will be over 10. So we have 2 answers to type in here. I have to come back over here. My mixed number, and I can click this button just to make sure I have all 3 pieces. So I have 8 3/10. That was my first answer here. And then I also have 83/10, like this. So this is improper because the numerator is larger than the denominator. But sometimes we need to know how to do this to complete some of our other calculations. It's more convenient to use an improper fraction, definitely sometimes, than a mixed number. So that's why they're having us convert those really quick. All right, next. Boop. All right. And I'll go ahead and clear this guy out. Can I? Yep, make that a little faster there. There we go. It's a little bit like a whiteboard. You can kind of still see that stuff there. It's kind of funny the way that it does that sometimes. Okay. So write 4.6 as a mixed number and as an improper fraction. So we're going to do the exact same thing we just did. So remember, this is 4 whole. What we're doing is we're trying to figure out what fraction this is. So we're going to move this over 1 and 10 because I moved it over 1. But it does say write your answer in simplest form. So with this one, 4 is going to stay 4. No matter what, that's a whole 4. But 6 and 10 I can reduce. They can both divide by 2. I'm not dividing the 4 by 2, only the 6 and the 10. So I have 6 divided by 2 is 3. 10 divided by 2 is 5. So this is reduced. It's the same exact fraction. 4 and 6/10 is the same thing as 4 and 3/5. It's just reduced. That's all. All right, and we also have to write it as an improper fraction. So remember, we multiply to figure out how many pieces there are here. So 4 times 5, there's 20 pieces in this 4. And then I have to add that back to the top there. So that's 23/5. Okay, so I'm going to hit this bar and 5 and 23/5. Check. Cool beans. Next one. All right, so write 21 and 4/5 as a decimal. So we have 21 and 4/5. The word and actually in math means there's a decimal there. So I know I'm going to have 21 and it's going to be a whole 21. What I need to do is figure out what this decimal is. So we can definitely kind of have our fraction bar out here. And it's 4 divided by 5. So 4 divided by 5. That's how we write it. Well, I can't necessarily do this. 4 is not big enough. So that tells me right away I have to add a decimal with a 0. This decimal goes straight up here, and that means that there's a 0 here. I could not go into 4. So we have a 0. I can go into 40, though. 5 does go into 40. So if I, count by 5s, 5, 10, 15, 20, 25, 30, 35, 40, that's 8 times. And that would be an even 40. So when I do my subtraction here, there's nothing left over, and I already have my decimal. So it'll be 21 and 8/10. 21 and 0.8. And it's the same thing. 8/10 would reduce down to 4/5. So it's the same idea. We're just writing it as a decimal there. All right, check. Perfect. Continue. All right. So we're going to write 9/16 as a decimal. So we have 9/16. So we're going to take this out, and we're going to go 9 divided by 16. So I can't go into 9. That's too small. So I know I have to add a 0 here. I can go into 90. So I have to think about this on the side and go 16 plus 16. And that's going to get me 12 and 32. So I can keep going as far as this. I could even do 2 of them, so I could do 32 again like that. I know there's 2 16s in here. So if I do 32, then there's 2 more 16s here. Right? This was 1 and 1. This was another 2. I'm just counting the 16s. So this was a little faster. Instead of adding 16 and 16 again, I can just add my 32s. If I did 32 again, and if I think about this, 30 plus 30 plus 30 is 90. So 32 plus 32 plus 32, well, that's going to be bigger, right? So we don't want to add 2 more. I'm only going to add 1 more 16 here, like that. And I'm just, again, this is just my count on my 16s on the side here. So I have 10, 6, 7, 8. So that gives me 80. So I was able to get to 80, and I used 1, 2, 3, 4, 5 16s. Oh, and I forgot to put my 0 and bring up my decimal. Goodness. All right, so I have 10 left over. I can't go in here, but I could go into 100, so I just add another 0 here, and my answer is just going to go straight up above here. So with this one, let's see, can I? Yeah, I just wanted to scoot that to the other side. Okay. So if I keep going here and I go 16 again, this is another 16. 6, 96. Oop, that's only 4 away. So I know that's as close as I'm going to get there. So I'm going to subtract that guy. And that was 1 more than I did before. But if I forgot that, I could go 1, 2, 3, 4, 5, 6. So there's 6. And then I'm going to have, let's see, I need to borrow. So this would be 10, but I'd have to borrow again, so 9 and 10. So remember, you have to borrow each time you have zeros. So 4, and that's 9 and 9, so just 4 is left over. All right, so I'd have to add another 0, and then the closest I could get would be this 32, because if I go more, 32 plus 16 is definitely going to be more than 40. So I know it's going to be 32. And that was only 2 of them. And let's see, what do I have left over there? I'd have, so I'd get 80. Or I'd get 8, left over. Add 1 more 0. Ooh, look, I have an 80 exactly right here. So that was 1, 2, 3, 4, 5. That was 5 of them. And we had already used that 80 before, but that came in handy. We didn't have to do that again. As long as I keep my count over here, that makes it really, really easy for me to go back and go, oh, I already got to that 80. The only problem with doing this 32 and 32 like I did there was if we needed a number in between, if we needed to know what 32 plus 16 was, we'd end up having to do that somewhere else. So be careful about that too. But hey, we have our number. So it's going to be 0.5625. So that's, let's see, that's 10,000. So 5,625 10,000s. Is that how you'd say that? Hope I'm not saying that wrong. I don't know if you'd actually say 5,000. I'd need to make sure I'm not saying that part wrong at the beginning. Whoopsie, why did it type like that? 25. So be careful, because that just moved over all of a sudden on me, and that would definitely give me a wrong answer. But Nice thing is Alex does give me a chance to fix it if I want to. Check. Yay. All right, next. Let's go ahead and erase these guys. Give me some more room here. All right, write 97 20 as a decimal. If necessary, use a bar to indicate which digit or group of digits repeats. So this one, I'm actually going to go ahead and take out a calculator because we do use calculators in here. So we don't always have to do the long division. This one is going to be a little bit more involved to do the long division with. And because it's saying, use a bar to indicate repeated digits, I'm thinking this does not end or terminate nicely. I actually wrote that backwards. Darn it. It's supposed to be 22 and 97. So we could do part of it because I could kind of think of twos and go 2, 4, 6, 8. That would be 8 and 8, right? So I know I can go to 88, which would be 4 times, like that. And then I'm going to borrow 17, and that's going to be 9. And now I'm going to have to start adding a decimal here, right? 90, we wouldn't be able to go more than 88. We'd have to go to that same one. So that would end up being borrowed. And 10, and we'd end up with 2, like that. So, and I have a feeling at this point it's going to start to repeat itself. It's just going to keep going over and over again. Oh, this would be another 4. I forgot to put that for the 88 here. So I'm going to test this out with a calculator real quick. So let me grab my calculator. There we are. So if we go 97 divided by 22, let's see what we get. Okay, so we do get 4, and then we would have gotten 0 because we can't go into just 2. So we would have received a 0 there, but the next number we would have had a 9, and then a 0, and then a 9, and a 0. So it definitely would have started repeating. So be careful on this one. So I'm going to actually fill it in here. When we put the bar, which we can grab right here on Alex, we do not want it over the entire thing. 4 is not repeating. Only the 0 and the 9 are repeating. So we do want to be very careful about that when we put our piece in here. So we want like this. And then if I click it there, so I think if I click it too early, what it does, I think it gives you 2 boxes anyway. But see, right now it's just putting the bar over the whole thing. If I did this, this would be marked wrong. So you want to be careful about that. If I type in 4.4 and then click my little bar button, then it works out much nicer. And there you go. It's only repeating what I want it to repeat. So just be careful about using the little bar feature, but you do have to indicate when it's repeating. So you have to know how to do that. Okay, next one. We have 4 and 21/25. So remember, I already know it's going to be 4 dot. That's a whole number. That whole number 4 is going to stay a whole number 4, even though I'm changing it to a decimal. So we can go back to our calculator here, which is dropped behind there. But so we can go, I'm going to clear it out. I always clear it out to make sure that there's no calculations in the background there, because sometimes if there's something kind of in waiting, it'll mess up your calculation, but you might not even realize that it did until you get the answer wrong. So I did 21 divided by 25. Make sure you type that in correctly. Can't tell you how often I watch students type that in backwards. It's the first number is the top, the numerator. The second number, what you're dividing by, is the denominator on the bottom. So we type in 21 divided by 25 equals 0.84. So this one actually probably would not have been too bad to do our long division with. That's pretty short. So 84, check. All right, continue. Write 2 and 12/13 as a decimal, rounded to the nearest tenth. So this one is asking us to round. We have to pay attention to that. So I know it's going to be 2 point. I already know that. This whole number 2 is going to stay whole number 2. I need to figure out the second part there. So I need to know what 12 divided by 13 is. And I'm typing that in my keyboard. That's why you can see the buttons flashing, but not my mouse moving so much. So I'm going to go ahead and hit equals. And there is my decimal. So it's a very long decimal. It's not necessarily, oh, it is repeating. I do see a repeating pattern. It's just kind of a funny one. So it's 923076, 923076. So this whole section is repeating. But we only want it to a 10th. So here's my 10th right here. I need to look at the number past where I'm rounding and make sure that it's not going to change my answer. So if it's 4 or less, everything just disappears. It basically turns to zeros. The 9 will just stay a 9. If this was 5 or bigger, then you'd have to round up your column you're looking at, or your row that you're looking at. But since it's 4 or less, it's just going to be 0.9. So I just go 0.9, and I'm happy with that. All right, check and continue. Okay, so we're going to write 0.67. Sorry, I said that really funny. 67 hundredths. I still said that funny. 67 hundredths? No, I said that right. Sorry, I'm just messing myself up here on the recording. 67 hundredths as a fraction, but it's repeating. So when it's repeating, we have to do it a little different. You actually end up using 9s instead of zeros. Okay, so I'm going to come over here still. We still have this 67. We still have to go 1, 2 like this. So I still have 67, but instead of 0, 0, 1, I'm going to go 99. So it's a little different when it's repeating. I have to put over 99. And I don't believe we can reduce that at all. I think that is, in fact, the answer. Ta-da! So if you could reduce it, you definitely want to go through and reduce it. With this one, I know that this is not divisible by 3 or 9, and this is only divisible by 3 or 9. So it was just one of those things that definitely helps if you know your numbers tricks, because there's a trick for every single number, 2 through 9, 2 through 10 actually, with the exception of 7. 7 doesn't really have a trick there, but all of them have this cute little trick that you can apply so you know if it divides quickly. All right, well, that was section 1, and I will see you in section 2.